the VTOMAN Jump 1800. So, team over at VTOMAN reached out to me relatively early on in my accepting reviews days. Something that, if you've seen my recent post, probably isn't going to be going on much longer, and this is probably the reason why. So they reached out and were initially really cool. Hey, we'd like you to review this power station. We don't really have any expectations. We just want a video that's about this long, and we'd like the rights to be able to post it on our website. They told me that I could say whatever I wanted to, could do whatever I wanted to with the unit. Really didn't put any major stipulations on it, so I was inclined to say yes. It was the largest power station that we had been offered to date. There were a couple of times where I was offered some like portable power banks, which really wasn't something I was interested in getting into reviews on. The company didn't even really give me a whole lot of details about the power station. I had to do my own research on it. So I found their website, found some basic details about the station, and then I went and watched a couple of other video reviews to get a better idea of what I was signing up for before I said, yeah, sure, send it over to me. Everything that I saw online seemed to be relatively good. The reviews were coming back good. People were saying that they were getting their money's worth out of them, and these were really going on sale for prices that were pretty unbelievable for what they say you get. So let's go over that real quick. So this again is the VTOMAN Jump 1800. Jump is because it has this jump starter port right up front here. We'll get to that here in a second. And the 1800 is because it can sustain a full 1800 watt load continuously. It claims to be able to peak out at 3600 watts. Again, more on that in a little bit here. And it does have quite a few different ports on the front, including 4 USB-A ports, some DC input jacks, our USB-C ports, which both can sustain up to 100 watts continuously. I did test that, and that reigns true. And then you've got 3 pure sine wave AC ports, which again are good up to 1800 watts total output. Everything seemed pretty good so far. Turn the unit on. It is relatively basic. There's also, just for the sake of showing, a light on the back here that you can turn on with this button. Light. So kind of cool. A few of you mentioned in some of my previous reviews that, or in some of the previous builds, that they thought this was a feature that really should stick around on power stations, especially if you're using them in an emergency situation. So good that they went ahead and included that. Other than that, you've just got vents on both sides and a little bit of branding from VTOMAN, and then a handle right up top. The unit itself feels well built. There were no rattles, creaks, or moans when I originally got it. It's very heavy. It's around 40 pounds, which is 17 to 18 kilograms, somewhere in there. The only real concern that I had before I took this unit apart was the handle up top was starting to get a little bit loose, and understandably something that could happen, but trying to tighten these 2 screws down led me to nowhere. They just kind of spun in place. So a little concerned on that as far as longevity, but wasn't going to necessarily be a deal breaker. Now, the taking it apart thing wasn't something that I had initially planned for this unit, at least not in the way that I did it. Normally, I want to get all of my testing out of the way first before I go and tear something down, because if I screw it up putting it back together, then obviously that's on me. So the way that I generally like to test these larger units to verify that they're able to actually output their claimed output amounts here is to plug them into an electric vehicle. So I'll use my Tesla with my level 1 charger, plug it in, and through the Tesla app, I can set how many amps I want coming into the car, which is going to, of course, determine how many amps are coming out of one of these units. I got my testing rig set up, went ahead and plugged it into the VTOMAN, and immediately got an error on my charger. Now, this does happen from time to time, usually not on the larger power stations, but on most of the smaller power stations, they don't have what's called a ground neutral bond. Now, just a real quick lesson on your home electrical system. In your home electrical system, at least here in the North America, maybe just United States, I'm not going to even speak for my neighbors to the north, your power comes in and you actually get 240 volts to the electrical panel that runs your house. That 240 volts is then split off to 120 volts to run the individual circuits in your home. They have a live, a neutral, and then if your system is within the last 50 to 60 years, you also have a ground wire in there. Some of the earlier homes may not have that ground wire in there. You probably already know about it because it's probably caused you some trouble in the past, and we're not going to touch on those. Normally though, your ground wire tied back into the neutral line on your AC panel. The reason why that is done is because if you do have a short somewhere, like say a lamp on the outside of your home, and you just have a ground there, in these kind of power stations, because they're not grounded, generally the ground is floating. So I needed to look into alternate methods to allow me to use my large load on a power station like this. Again, I could plug in maybe a few hundred watts here and there, but being able to pull down 3,600 watts is going to be near impossible with some of the electronics that I have here. So really needed to be able to plug the car in. And that's where this little guy came in. Now, what this is just the end of a standard AC plug. For those of you that aren't familiar, this is a US type plug. So you've got your ground here, your live and neutral wires. And what I've done is snipped the end off. I have connected the neutral with the ground, leaving the live wire by itself, which then allows me to plug it into a unit like this. And in theory, the other two outlets should now have that neutral ground bond. Went ahead and plugged my Tesla charger in, and once again got an error. So what gives? Well, now I've got a good excuse to take it apart, so we did just that. Now, first thing I wanted to take a look at was going to be that rattly handle. Again, I hadn't had the unit for very long. It had only really been carried from my car to the workshop and maybe back and forth from the front of the workshop to the back of the workshop a couple of times. And the handle had already become loose. You'll see it's tight now. That's because, of course, I mitigated that issue. But taking this apart, I took these 4 screws out and went to try and take these 2 out. Took the lid off and realized that they had in fact not used any Loctite on the nuts that are holding these 2 screws in. They're also not captive into the plastic in any way. What that means is that if this is maybe your travel companion, something you keep in your truck or in your RV, and over time the vibrations from that car cause that nut, which it wasn't a lock nut, it wasn't a nylon fastener or anything like that, but just a standard galvanized steel nut. If it causes that to come down and fall into the unit, then as you'll see in a second, that can cause you a lot of trouble because there's a lot of potential energy in here and not a lot of protection. Now, that in and of itself wasn't going to be a big deal. I sent the manufacturer a message and said, hey guys, you might want to look into that. And they agreed and said, yep, definitely an oversight. We went ahead and continued to tear the unit down, and the main inverter really didn't look that bad. Most of it, granted, was covered in a plastic shroud, which is used to carry the air out of the unit when it gets really hot, using fans on either side, something I like to see, I will mention. So I really didn't have any complaints right off the bat. Taking the unit apart a little bit further, the unit had a level of jank that I don't expect normally out of a unit of this price point. Mind you, this unit normally sells for around $550. That's the price that they ask for it on Amazon if you get it with the jumper cables. Now, some of the things that I noticed that caught me off guard immediately were some solder joints that appeared to be cold joints, although taking a second look at it, maybe they weren't. Maybe they were just pulled up in certain areas where there wasn't any kind of anything for them to actually stick to. I noticed that the BMS as well as the inverter appeared to be engineered in a significantly undersized way. The reason why I say that is because all of the traces on these boards were reinforced with very thick copper bars. Now, the only reason you would take the extra time and frankly the extra cost of putting a large pure copper bar onto the board like that is if you ordered the PCBs originally without considering the amount of current they were going to carry. What I believe is going on here is this unit was originally made for the Chinese or EU market, where they use 240 volt electricity. Because of that, the traces on the boards don't need to be as thick. They carry a lower amperage to carry the same wattage. Now, this company decided to break into the US market, and rather than redesigning the product, they simply decided to change some of the components on the product to make it work with 120 volts. And then they simply beefed up the componentry to allow it to take that extra amp load. Is that necessarily a bad thing? Not necessarily if it works. It's janky, absolutely, and it does show a lack of oversight on the company's end, but overall it's just adding extra paths for current to go down, and in theory that should work just fine. Now, the other componentry that we saw on the board did indicate that this was an older style, while still being pure sine wave, an older style inverter. It's more than likely not going to have the efficiency, and we will see that when we get to the testing a little bit later. Now, looking at these front panel connectors, the one thing that I wanted to find out is why my neutral ground plug didn't work. And as you'll see here, unfortunately, the ground lines, they're not connected to anything. So not only are they not connected to each other, allowing a ground to potentially go across multiple devices, they're just floating out in air. So that is why ultimately our neutral ground bond didn't work. Now, looking further into the BMS and some of the jank on here, I frankly wasn't sure if I was going to reassemble this device and even give it the light of day as far as testing goes, but ultimately I told this company I would make a video, and whether it's a good or a bad video, I need to have some numbers to back it up. So I did go ahead and reassembled everything. I didn't fix that issue, but found a different way to allow me to test the load on here, at least to a minimal extent. The first thing I wanted to do is test the DC output here. The protection that they use on that front panel is not temperature based. It is in fact simply wattage based, and it does cut off if you attempt to pull more than 300 watts out of a combined total of these ports. With that said, it does appear that the cooling system within this power unit is not tied to that front DC panel. While I was testing this, pulling down very close to 300 watts for about half an hour, some of the componentry on this front board got upwards of 200 degrees Fahrenheit. For those of you overseas, that's close to 100 degrees Celsius. It's pretty high and not something that made me super comfortable. Now, ultimately my DC loads, which were again just a bunch of batteries, they ended up eventually filling up to the point where I couldn't pull that full 300 watts, and the unit did sustain it without ever choking or having any trouble. But the fact that it got that hot and these fans never turned on, again, caused me a little concern. Now, my next step was to do a drain on the unit and see if I could get that full 1800 watts. So I hooked up 3 of my other external batteries and was able in their app to set the charge current to allow me to pull exactly 1800 watts from this unit. And it did it without breaking a sweat. These fans, they do get pretty loud, and the internal componentry does get really hot. The main transformer inside of here got over 200 degrees. It was ranging around 206 to 208 degrees, even with these fans running full blast. And that's with its shrouding and everything to be able to control the airflow through there. So pretty hot, but again, didn't fail, didn't seem like it was going to. And while I was able, while I had those devices plugged in, albeit at a slightly lower charge, I had to have only 2 of them plugged in to test this last port. I did grab an oscilloscope and checked, and it did put out a pure 60 hertz sine wave without any trouble. There was very, very minimal ripple even at some of the higher loads. So it did sustain 1800 watts, but anytime I ask more than that of it, it would fall on its face. I attempted to get up to around 1900 watts. That was around the max that I could pull out of the devices that I had available to me. And this unit at 1900 watts only powered on, or only stayed on rather, for around 30 seconds before it completely cut off. So really that 1800 watts, that's going to be your limit. It says it can do a burst up to 3600 watts, and I'm skeptical of that. Again, unfortunately, didn't have a way to test it, so because of that, I just kind of have to take their word at it, but I wouldn't expect that more than maybe just the quick trip of a compressor turning on, that this is going to be able to survive a sustained load above that 1800 at all. Now, the other thing I wanted to test on here was going to be the capacity of the unit, and this unit makes that interesting. With this unit, it only charges off of these 2 DC ports right up front here. and it is maxed out. It can only charge at a maximum of 400 watts. Now, the charger that they provide with it, it is very, very substantial, and it does provide around 375 watts. But because we could only charge through these kind of barrel jack connectors, I was limited on how I was able to calculate how much capacity was going into this unit. So went ahead and drained it completely, got it down to 0%, and allowed it to sit for a couple of days to make sure that it actually was at a full 0% and it wasn't just an issue with maybe the batteries inside fluctuating down below the amount the BMS would see. And then I wired up an inline shunt between the charger that they provided me and the DC outlet to allow me to find out exactly how much wattage was going into this unit in DC watts. Now, you do generally expect a little bit of a conversion difference when you are charging a device, whether it be by AC or by DC. DC is going to be a lower conversion, usually between 3 and 5%. Plugging in my shunt to the front of this device and allowing it to charge over the matter of 5 to 6 hours, which is unfortunately the fastest this can charge. It also wouldn't be able to do UPS mode just because the output here is substantially greater than what it is able to input. So because of that, you're not going to be using this as a battery backup, but just as a backup battery. Sure. Plugging it in here, I charged it a full 2 times. I wanted to go ahead and charge it, drain it, and charge it again, which a little bit of a 2-day process. Now, in both cases, I got very, very similar numbers. The first charge on this guy, I got 1,516 watt hours. And on the second charge, I got 1,518 watt hours. Now, that sounds close to the amount that they rate this for. If you look at the back of the unit, they actually rate it for 1548. But again, when you're considering in that efficiency loss, I should have been putting more than 1548 into this unit. The battery cells are legitimately lithium iron phosphate prismatic cells, which is great. They use a good heavy gauge wire inside of the unit here. Now, when I charged some units off of the AC on this guy to find out what the efficiency was of the AC inverter, I got some disappointing numbers. So out of this unit, I was actually only able to draw around 1,060 watt hours. That means that out of the 1515 that we were expecting to get out of it, we only drew about 70% of that. The AC efficiency of most modern electronic devices are anywhere from 80% upwards to 93, 94, 95%. To only pull 70% out of this means that even though you have a relatively large battery, you're really not able to use it. So what's the point? Now, I expect that that has to do probably with the way that this was developed. And again, my suspicion on that is just that this was a device that was adapted from a different market and wasn't originally made to work in a US market where the voltage is a little bit lower. Now, on top of all the issues that I found inside of the unit, one issue I found right inside of the box. Again, when I did my initial research on this unit, it's called the Jump 1800 for a reason. It's meant to have a jump starter functionality that, based on the claims I saw, were saying that it could jump start up to a 7-liter diesel or a 9-liter gasoline engine off of just this port right up front here. Now, I took a look at this port and saw something that looked pretty familiar to me. It looked very similar to a standard that you see called EC5, and you generally see them on jumper cable boxes just like this. The port here, though, is unfortunately just a little bit different. Now, initially my thought behind this was, well, there goes another company just trying to snag a buck from you, and they're putting out the same exact device you can get for 10 bucks on Amazon for an extra $50 in their bundle, but you have to buy theirs. And while that may reign true for a lot of items, I don't know that that's the case on this one. There is a significant quality difference in the one that they provided, which is ironic considering the device it's plugging into. But the wire gauges are, while very similar, going into different connector types. You'll notice that there is a pretty big difference in the size of the connectors, and one thing you may not be able to see from there is the difference in the amount of copper you get inside of this connector. It is a thicker connector on my right-hand side here versus this guy up here. They are a little chunkier, and the connection that goes between the two jaws is very, very tiny on the aftermarket unit versus the VTOMAN, which uses around I'd say 10 gauge wire instead of the 8 that's going into the actual unit itself. Now, they claim that their jump starter can output up to 800 cold cranking amps, whereas the cheap one off of Amazon generally claims around 600 cold cranking amps. Are you going to really notice a difference? Maybe not. And unfortunately, there's no way for me to test these. Now, while that extra functionality is great, I would caution anyone that decides to get this device to use that functionality very sparingly. The connection for this external port actually only connects halfway through the battery itself. So out of this 26 to 28 volt battery, the vehicle plug only plugs into half of the cells inside of this unit to get between usually 13 to 14 volts as a nominal voltage for this kind of jump starter. What that means is that if you use that jump start functionality consistently, if this is a unit that you're using just for jump starting, half of the battery is going to be drained more and more rapidly than the other half. Eventually, that's going to mean that these batteries are going to come out of balance and continue to degrade more quickly and potentially give you a lower lifespan, as well as lower capacity that you can actually pull from the unit at any given time. So out of the VTOMAN Jump 1800, the only thing that seems to reign true is the 1800. It can sustain that load, albeit at an efficiency that doesn't make a lot of sense for an emergency backup. If you're going to be using an emergency backup, you want something that is as small and light as possible. You don't want to carry around extra capacity that you can't use. You also generally, at least down here in Florida, don't want a device that's going to run quite as hot as this guy. This is going to be pumping out 200 degrees out of its exhaust the entire time it's running. And when I'm working on something for a hurricane, I don't necessarily want an additional 200 degrees on top of the 100 degrees, 100% humidity that it's already going to be outside. Ultimately, this unit for me is a pass. It doesn't have the capability of running some of the high-end loads that you would need this thing to run because of that grounding fault. The componentry on the inside really feels piecemealed together, like they're taking parts out of the waste bin, throwing them together, and then trying to charge a premium for them. The main functionality, at least the main function of the name, the jump part, seems to be not only a proprietary connector that you have to pay extra for unless you buy it with a bundle, which the bundle price didn't make much sense. It was an extra $50 for it bundled with the connector, or you could do like I did and buy this connector off of Amazon for $20. Also, the fans only have apparently have one speed in here, and that is they're either off or they're extremely loud. The unit itself, as the company said, was built to a price point. I brought up all of these concerns and some others that I was wrong about initially, and they took it gracefully. And they did say that they would provide this feedback to their engineer team and they would work to do better in the future. But as it stands right now, I haven't seen that, and I don't have a lot of faith that they're going to make many changes. Per my obligation to them, at least what I told them I would do, I'm still going to put this video out, which I have, and I will include a link to the product down in the description as well as the pinned comment. I trust that you guys probably, hopefully watched at least to this part, and I can tell you that I would hope you wouldn't use that link. I'm not going to sign up for their affiliate program because I don't want to make any money off of this unit. And frankly, I suggest going a different route. That's my honest opinion, and that's what you guys are here for. So, sorry VTOMAN, we missed the mark on this one. This is going to be about it for reviews for me. I've got 2 other devices that are coming in and 2 others that I've kind of put on hold up until now just because I haven't had a use for them. And I'm going to get those reviews out, and then that's going to be it, at least for a while. These kind of devices really kind of soured me on this. Having to put out a video and invest a lot of time in something that frankly kind of sucks, it's not fun. So, we'll see you guys in the next one. If you do like this kind of video, I would normally say here, like and subscribe, but again, I'm probably not going to be doing too many more of these. And I've got a lot of projects coming up that are going to probably keep me away from spending money on these kind of things. But if you do like to see projects in the garage, if you want to see some other things, or maybe just some honest opinions about some of the devices that I like to work on, feel free to stick around, hit that like and subscribe. Other than that, y'all, hopefully I'll be back here next week with another one, and something maybe a little less negative. We can hope.